Our third part of today's lesson is a little bit of a twist on the part we just spoke about, the exponential growth. To begin with, what kind of numbers keep getting smaller the more you multiply them? Like if you take the number 2 and keep multiplying, it goes 2, 4, 8, bigger, bigger, bigger. But if you take a fraction, specifically a fraction or decimal that's less than 1, so really something between 0 and 1, the more you multiply it, the smaller it gets. A half of a half of a half of a half gets smaller and smaller and smaller. So if we try an exponential function where the b is a fraction, so it would be y equals, I'm just going to leave a as 1 for now, 1/2 to the x. Well, this time, the more you multiply, so we'll start with, we know that anything to the 0 power is 1, but the more you multiply, so the bigger your exponent gets, 1/2 to the first, 1/2 to the second, 1/2 to the third. The more you multiply by 1/2, the smaller you'll get. But if we were to flip it around and start using negative exponents, 1/2 to the negative first is the reciprocal of 1/2. 1/2 to the negative second is the reciprocal of 1/2 squared. And we can see those values look just like the same values as our last graph, y equals 2 to the x, except now they're in reverse. They're backwards. This type of graph has a name. It's called exponential decay. It really is just about the same thing as exponential growth, but going in the opposite direction. So we've got the points 0, 1, going forwards 1, 1/2, 2, 1/4. It would keep getting smaller and smaller. But moving backwards, our numbers would go up. Negative 1, 2, negative 2, 4, negative 3, 8 would be next. And this is going to look exactly like our last graph, only flipped backwards. That is exponential, or this has a name. It is called exponential decay. Anytime the base of the exponential function is between 0 and 1. We have the same horizontal asymptote as before, except this time the horizontal asymptote is on the right-hand side. So the y will get closer and closer to 0. So our end behavior will be the opposite of last time. There is one other way, I'll come back to that in 1 second. There is one other way to see exponential decay. We can either do what we just did, which is put a fraction in the base, and when you raise a fraction to a positive exponent, it's a smaller fraction. When you raise a fraction to a negative exponent, it becomes a whole number again. Or we could say that our original function, we still have a nice simple base of 2, but if we put a negative in front of our exponent, that will accomplish the same thing as making our base into 1/2, because now whenever I have a positive x value, that would translate to a negative exponent because there's a negative right in front of it. So 2 to the negative first, 2 to the negative second, 2 to the negative third. On the other hand, when x is negative, like negative 1, negative 2, well, now there'll be a negative in that x, so we'll have a double negative in the exponent. 2 to the negative negative first is 2 to the first. 2 to the negative negative second is 2 to the second. And what we end up with is exactly the same graph as 1/2 to the x. So we have two ways of writing the same exponential decay. And either way we do it, the graph looks the same in the end. So there are two ways to recognize it in the equation. And so one of your jobs is often to identify very quickly whether a function is exponential, growth, decay, or neither. All you're looking for is the base a fraction less than 1 or bigger than 1? Is the exponent by itself, or does it have a negative in front of it? If either of those two situations are true, then the function is exponential decay. Like in part A, because the fraction is the base, it is exponential decay. For part B, I don't really care about the 0.5. That doesn't matter to me at all. What matters to me is that the base is bigger than 1, so this is exponential growth. Same thing in part C. 6/5 is bigger than 1. It doesn't matter if it's written as a fraction. It's bigger than 1, so that's exponential growth. So bigger than 1 is exponential growth, less than 1 is exponential decay. That middle point, when the base is exactly 1, that is neither exponential growth nor exponential decay, because 1 to the x is always 1. So this is the same thing as the graph of y equals -5. It's just a horizontal line, not growth or decay. Part E is a little bit tricky. 3 times -2 to the x. Again, the 3 doesn't matter to me, but that negative is a problem here. Exponential functions can't have a negative base, so that is neither exponential growth nor exponential decay. And in part F, we're looking at a base that's less than 1, but also a negative in the exponent. Those two things cancel each other out. So this ends up being exponential growth.